Hey guys, Mr. Gucci here to introduce your Independent Work Wednesday activity, which is going to be an equation balancing simulation. Now, I'm going to start off with a conversation with you about recipes. Here's a recipe for the perfect vanilla cupcake. Now, what is a recipe? A recipe is just one way of writing down a chemical equation. All right, remember from previous units, a chemical equation lists the formulas of the reactants, the substances that you start with. And then you have a little yield arrow, and it describes the products also that are formed. For example, here's a chemical reaction: iron 3 oxide plus aluminum metal has a chemical reaction to form aluminum oxide and iron metal. That is an example of a chemical equation, okay? A recipe is just a chemical equation, except instead of listing the reactants, we would just call them ingredients. In this case, the ingredients are flour, baking powder, salt, sugar, and so forth. And instead of listing the products, it just tells you what are you making. You're making cupcakes here. Now, as you know, with an actual recipe in a cookbook, it's not enough to just say that you need flour, baking powder, salt, sugar, pure vanilla. It's not just enough to list the ingredients. You also need to describe how much of each ingredient you're going to need. So it's not just that you need all-purpose flour. In order to successfully pull off this recipe, you need to know that it's 1 1/4 cups flour, 1 1/4 teaspoons baking powder, a half teaspoon salt, a half cup softened butter. Okay, without the actual ingredients, you might mess up. Maybe you'll put in only a teaspoon of flour. Maybe you'll put in 1 1/4 cup of baking powder. Maybe you'll put in a full cup of salt, and they'll be the worst cupcakes you've ever had in your life. Okay, it's also important to know how many cupcakes am I making here. All right, this is only a dozen cupcakes, so that's cool for like a small get together of friends. But if you're doing a large birthday party or baking for a bake sale, you're going to need to make more cupcakes, which means you're going to need to increase this recipe, right? A recipe is not just the list of the ingredients that you need. The recipe is also how many of each ingredient you need and how much of the final food item you're making, okay? And it's the same for chemistry as well. This equation right here just tells us that we need iron 3 oxide and aluminum. And it tells us that we make aluminum oxide and iron, but it doesn't tell us how much of each we need. All right. And so this is not actually a complete recipe. I mean, just look at this recipe. We start off with 2 iron atoms and we end with 1 iron atom. We know that's impossible based on the conservation of mass and matter that we learned previously in this year. All right. If you start with 2 iron atoms, you have to end with 2 iron atoms. If you start with 1 aluminum atom, you can't end with the 2 aluminum atoms. Where did that aluminum come from? It violates the law of conservation of mass and matter. So if you wanted to pull off this reaction, it's not just enough. By the way, this reaction is called the thermite reaction. It's like really super cool. I'm going to show you a video of it right now. But if you want to pull off this reaction, it's not just enough to know what ingredients you have, but how much of each ingredient you're going to use. So this is the reaction, the thermite reaction. And here's how it works, okay? Here are a couple of guys who are laying down new railway line. Now, these rails are made of like iron, but they come in like sections that are only 50 feet long. How do they attach them together? Well, what they do is they use the thermite reaction. All right, over here, we see the thermite reaction. One of the things it produces is iron metal, and it produces iron that is so hot that it's actually a liquid, and it flows into a gap between these two rail lines and melts into place, sealing these two rails together. So here we go. Here we go. All right, this bucket right here is a disposable bucket filled with iron oxide and aluminum. He lights the fuse, throws it in, and a reaction occurs. It gets so hot that it actually melts through this metal container here, and liquid iron flows in between the rail lines. So you can see it pouring into place right now. and welds these two rails together. Now, this is a job that happens to pay, particularly well because it's a very dangerous work that involves very dangerous chemistry. So if this is something you wanted to do, you'd have to know chemistry and you'd have to know how much iron and how much of the iron oxide and how much aluminum you'd have to combine together. Okay, let's hear. Fast forward, fast forward. They remove the mold. All right. They remove the mold. Let's see here. Okay, yeah, and you can see it just liquid iron melted in between these rails, and now they're going to separate out the excess iron and grind it flat. Okay, so that was the thermite reaction. If they did not add enough aluminum uh, powder or iron oxide, the reaction would not have worked. There'd be all kinds of other gross stuff mixed in there, and the rail weld would fail, and the train would go off the rail and potentially hurt or kill a bunch of people. All right, so that's real important chemistry. By the way, this is the thermite reaction. If you're interested in looking up a bunch of thermite reactions, they're really super cool. This internet guy sees if he can melt through a safe with a bunch of thermite. All right, let's see what happens here. Okay, so there we go. He lights the fuse and he runs away because this is real dangerous. Okay. Oh, watching, watching, watching. Whoa! All right. That was about 10 pounds of thermite that he melted right there. Anyways, this is just to prove the point here that you have to balance this equation. Okay, now the way we balance the equation is, like I said before, you have to make sure that you have the same number of each type of atom on each side of the equation, on the reactant side and on the product side. Here's an example. This is the chemical reaction that is used to produce hydrofluoric acid, one of the strongest industrial acids known to man. This stuff can actually melt through glass. You cannot store it in a glass container, it will eat through the glass. So let's try and balance this equation right here. And let's take a look, okay? We see how on the reactant side we have two fluorines, all right? But on the product side, we only have one fluorine. Two fluorines here, one fluorine here. That's not good. We need another fluorine. But we can't just add a single fluorine. We have to add two hydrogen fluorides, two hydrofluoric acids, okay? So we click this number up to 2. Now we have 1, 2 fluorines, 1, 2 fluorines. The little red guys are oxygens. We have 1, 2 oxygens. We have 1, 2 oxygens. We have two little white hydrogens right here. 1, 2 hydrogens. 1, 2 hydrogens. So take a look. This is a balanced chemical reaction. We would call this chemical reaction balanced. And this is how we know that we have the actual recipe of this reaction. The recipe for this reaction is if you combined one oxygen difluoride with one water molecule, you will produce one oxygen molecule, one O2, remember it's diatomic, and two hydrogen fluorides. Okay, so that's the reaction. One and one combined to give us one and two. Okay, now take a look. As soon as I do this, I check my answer. Hey, it's balanced. It's correct. All right, I'm going to try another problem. This right here, this reaction is the combustion of methane. Okay, now I'm going to start with one of each of these things. Let's take a look here. This gray circle, we see here, CH4s, one C and four H's. So the one thing here is the C, the carbon. I have one carbon on this side, and I have one carbon on this side. So that's good. That's balanced. Okay. I have one, two, three, four hydrogens on this side, and I have one, two hydrogens on this side. That's not enough. Right? I have four over here and only two little white hydrogens over here. Something clearly got lost along the way. All right, we can't just go from four hydrogen atoms to two. You can't destroy atoms in a chemical reaction. So I'm going to increase this coefficient and say, what if we produce two waters? Now we have one, two, three, four hydrogens. One, two, three, four hydrogens. Okay, great. So I've got one carbon, one carbon. One, two, three, four hydrogens. One, two, three, four hydrogens. Very good. Let me check my answer. Uh-oh, it's not balanced. Well, here's the problem. I have 2 oxygen atoms over here, and 4 oxygen atoms over here. So I need to increase this. All right, now let me check. Okay, this is balanced. So the recipe for burning methane gas, all right, which is the chemical reaction that occurs in a lot of our gas heated homes, okay, is 1 methane molecule plus 2 oxygen molecules will result in 1 carbon dioxide molecule and 2 water molecules. This is the balanced chemical reaction. Very important, okay? If you were to design a water boiler that would go in someone's house, well, you'd have to make sure that for every 1 methane that's introduced, you introduce 2 oxygen atoms. If you introduce too much oxygen, you might stall the chemical reaction. If you have too few oxygens, well, you might not burn all the methane that's coming in, and then you might get methane buildup that could potentially explode and destroy an entire house. Okay, so this is going to be your activity for the day. You are going to be balancing chemical reactions. Okay, you are going to go follow the PHET link. You're going to do the introduction here first, and you are going to balance these 3 different reactions. You are going to make ammonia, you are going to separate water, and you are going to combust methane. You are going to increase the number, this coefficient here, to try and get everything to balance out. Okay, I'm just messing around here. I'm not getting to a right answer. Okay. Oh, here I am. Okay, so you're going to do this now. As soon as you balance each equation here in your mini lab, you are going to type out what were the coefficients that you needed. Okay, knowing that combusting methane is CH4 plus O2 and it yields H2O and CO2, okay, that is just the ingredients list. You need to tell me how much of each stuff you need. You need to turn this from an ingredients list into a recipe, okay? Cool. So there you have it. That's your activity, okay? You are going to do the introduction and then fill in the coefficients here as you go. Then, then you are going to go to the game and you are going to play the easy level game. Now, there's 3 levels of game. There's level 1, which is easy, level 2, which is medium, and level 3, which is hardcore. Okay, you're going to for this lab, you're going to do the introduction and the level 1. Okay, you are going to balance this equation out. Okay, now here we go. Let's see here. So 1, 2 nitrogens, 1, 2 oxygens, 1, 2 nitrogens, 1, 2 oxygens. Let me check is the balanced equation. Very good. So in your lab, you would type 2 NOs. All right, 2 NOs. And what they yield is 1N2 and 1O2. All right, so they yield 1N2 plus 1O2. Now I got to make sure that I use subscripts here. This is a chemical equation, all right, as we've been working with before. It's a formula. Text format subscript. All right. Format text subscript. There we go. So your assignment is to do the introduction and then do the easy equation balancing problems. All right. Good luck, everyone. Please email me with any questions that you have.